हेलो फ्रेंड्स, नमस्कार। क्लास 12 चैप्टर 8 इलेक्ट्रोमैग्नेटिक वेव्स के एक और सेशन में आप सबका स्वागत है। आज हम एग्जाम्पल सॉल्व करेंगे और ये बहुत छोटा सा वीडियो है जिसमें हम थोड़े से ही एग्जाम्पल सॉल्व करने वाले हैं। क्या है देखिए, अ प्लेन इलेक्ट्रोमैग्नेटिक वेव ऑफ फ्रीक्वेंसी 25 मेगाहर्ट्ज। क्या फ्रीक्वेंसी दी है? फ्रीक्वेंसी इज 25 मेगाहर्ट्ज travels in a free space along the x direction। ओके, कौन सी डायरेक्शन में ट्रैवल कर रही है बच्चों? एक्स डायरेक्शन में। ठीक है। एट अ पर्टिकुलर पॉइंट इन अ स्पेस एंड टाइम ई इज इक्वल्स टू दिस मच। व्हाट इज बी? ओके, इलेक्ट्रिक फील्ड इज गिवन। इलेक्ट्रिक फील्ड क्या दिया गया है बच्चों? देखिए 6.3 जे कैप वोल्ट पर मीटर। ठीक है, ये इलेक्ट्रिक फील्ड दिया गया है बच्चों। तो हमें मैग्नेटिक फील्ड चाहिए, पहले मैग्नीट्यूड फाइंड करना है। ई अपॉन बी इक्वल टू सी। तो B इज इक्वल्स टू हम क्या बोल सकते हैं? E अपॉन सी। तो E क्या दिया है? 6.3 और C क्या है? 3 इंटू 10⁸ ओके, सो व्हाट यू कैन से इट इज 2.1 इंटू 10⁻⁸ टेस्ला। ओके, नाउ डैश क्रॉस डैश इज इक्वल टू डैश, जैसा कि हम फाइंड करते हैं। पहले में इलेक्ट्रिक फील्ड आएगा जो कि ऑलरेडी दिया है, मतलब कि जे कैप। दूसरे में मैग्नेटिक फील्ड जो अभी हमें फाइंड करना है। तीसरे में डायरेक्शन मतलब कि आई कैप। ठीक है, तो जे कैप क्रॉस, अभी यहाँ पर देखो के कैप आएगा या तो माइनस के कैप आएगा। तो आपको अच्छी तरीके से अगर पता है आई जे और के, तो आई क्रॉस जे के होता है और जे क्रॉस के आई होता है। सो जे क्रॉस क्या होना चाहिए? के। Okay, means electric field is in the J cap and magnetic field is in the K cap. So directly I will write like this: B bar is equals to 2.1 into 10⁻⁸ K cap Tesla. Okay. Hmm. This is example important for a 2 marks. This example is. Now see this example. The magnetic field in a plane electromagnetic wave is given by By is equals to, okay, magnetic field is given. See, what is the wavelength and frequency of the wave? First of all, see the magnetic field equation. B0 sine, you can say kx plus omega t. Okay, or omega t plus kx. And I am writing like this: 2 into 10⁻⁻⁷. Okay, magnetic field is in the y direction. Okay, here sine 0.5 into 10⁻³ plus 1.5 into 10⁻11 t Tesla. Okay, what is asked? What is the wavelength and frequency of the wave? So first of all, let us calculate the wavelength. So k is equals to 2 pi by lambda, right? K is equals to 2 pi by lambda, implies lambda is equals to 2 pi by k. Okay, now 2 pi, 2 into 3.14, and k value is given here 0.5 into 10⁻³ Okay, so what you can say here is that 0.5 means 1 upon 2. So if it is going in the numerator, then 4. So you can say 4 pi into 10⁻³ meter. So that is the wavelength. And how to get frequency? See, omega is equals to 2 pi f. Right. Now omega, how to find out omega? See, as we have discussed that it is a k, in the same sense it is a omega. So 1.5 into 10⁻11 is equals to 2 pi f. Okay, means f is equals to 1.5 into 10⁻11 divided by 2 pi. So this much hertz will be the frequency. Okay, so first is solved. Now second, write expression for the electric field. Students, what is this? This is a B0. So first of all, let us calculate what is the E0. E0 is equals to what? B0 into C. Now what is B0? B0 is 2 into 10 raised to minus 7 and C 3 into 10 raised to 8. So what is that? It is a 60 volt per meter. Now let us calculate the direction. How to calculate the direction? Is we have calculated in the above example, dash cross dash is equal to dash. Okay. First is for the electric field, second is for magnetic field. Magnetic field is in the y direction. So I will write here j cap. Then after here positive x means wave is traveling in the negative x direction. I am writing here wave is traveling in negative x direction. Like this you can say that wave is traveling in the negative x direction means what? Here it will be minus I cap. Okay, so here it will be either k cap or minus k cap. If k cap cross j cap then minus I cap. Okay, then right, then here it will be k cap. Okay, that's for sure. So what you can write about electric field? Electric field will be in the z direction. Okay, and it will be given as the 60 sine 0.5 into 10 raised to 3x. See, bracket will remain as it is. Whenever you are writing this type of expression, at that time bracket will remain as it is. Clear to you? Okay, volt per meter. So this is the expression for the electric field. Okay, now let's see next example. What is given? That a light with energy flux 18 volt per centimeter square. 18 volt, sorry, 18 watt means in 1 centimeter square how much power is get delivered? 18 watt means in 1 second 18 joule power is get delivered. That you can think like that. Okay, now what is given? On a non-reflecting surface. Non-reflecting means what? Totally get absorbed. Okay, if the surface has an area of 20 centimeter square, find the average force exerted on the surface during 30-minute time span. Okay, fine. First of all, let us discuss that how much energy delivered. Energy delivered. Energy delivered will be is equals to 18. Okay, 18 watt per centimeter square. Okay, it's multiplied by how much area is given? 20. Okay, 20 centimeter square. So it get cancelled out. Okay, so in 1 second, but we are interested in how much time? 30 minutes. So 30 minute, but 30 into 60, so it will get converted in the second. So what is the answer? It will be 18 into 20 into 30 into 60. Okay, so the answer will be 6.48 into 10 raised to 5 joule. 6.48 into 10 raised to 5 joule. This much energy is get released. Okay, sorry, delivered to the wall. And because wall is completely absorbing this, completely absorbing this energy, whatever energy incident on it, wall is completely absorbing. Therefore, momentum transferred to the wall, momentum transferred to the wall. Okay, how much momentum is get transferred to the wall is equals to, suppose this is a u, so that is a u by c. Okay, so 6.48 into 10 raised to 5 divided by 3 into 10 raised to 8. Okay, so 3 to the 6 and 3 1 the 3 and 2.16 into 5 minus 8, so 10 raised to minus 3. Okay, kilogram meter per second. So this much momentum is delivered. Okay, now force is equals to what according to Newton's second law? Delta P upon delta T. So this much 2.16 into 10 raised to minus 3. This much momentum is get delivered in how much time? 30 minutes. Means what? 30 into 60. Okay, so if you solve this, then you will get answer 1.2 into 10 raised to minus 6 Newton. Okay, see if wall is completely reflecting this, see if wall is completely whatever energy incident it completely reflected, then how much momentum get transferred? That will be 2u upon c. Okay, as we have discussed in the mechanics, it will be 2u upon c. Sometime it is given that some percentage get absorbed and some percent get what you can say reflected. Suppose it is given that 30% get absorbed. 30% absorbed means what? 60% get reflected, 60% reflected like that. Okay, if it is given, then what will be the momentum? That will be u upon c into 0.3. Okay, this is for complete absorption, and then after 2u upon c into 0.6. Got it? Why 2u upon c? Because it is reflected, that's why. So if this type of example is asked, then you have to follow these rules. Okay, fine. Let's see next example. Calculate electric and magnetic field produced by the radiation coming from the 100-watt bulb. What is the power? Power is 100 watt. Okay. At a distance of 3 meter. So what is the distance? R is equals to 3 meter. Assume that the efficiency of the bulb is 2.5%. What is the efficiency? Efficiency is the 2.5%. Means what? Light energy is equals to 2.5 into 100 upon, मतलब कि 2.5% हमें किसका निकालना है? 100 अपॉन 100 ऐसा बोल सकते हैं. तो ये कट हो गया. So how much it is? 2.5 joule per second. Okay, this much light energy get incident. Okay, and what we have to calculate? Electric and magnetic field. Clear? Okay, so you can say this is a power. Now because this is a point source, you can imagine that it emits light in 360 degrees, means everywhere. So intensity will be is equals to power upon area. Intensity is equals to power upon area. Now what is the power? Power is a 2.5 and area is equals to 4 pi r square. What is the r? 3 meter. So 2.5 4 pi into 9. Okay, so this is the what? Intensity. Now see, I will show the direction only. See, we got the intensity. Clear to you? Okay. Now, intensity I equal to rho c. Intensity I equal to rho c, and rho c is equals to, you can say, epsilon 0 E square RMS into C. So we got the intensity. So E square RMS is equals to I upon epsilon 0 into C. Okay, or you can say E RMS is equals to under root of I upon epsilon 0 into C. Now what is I? That already we have written here, 2.5 upon 4 pi into 10 into 9, or epsilon 0. This is epsilon 0. It is 8.85 into 10 raised to minus 12, and C is 3 into 10 raised to 8. So in this way you can get ERMS, that is a 2.9 volt per meter. And once you got ERMS, you will able to get BRMS also. How? ERMS upon BRMS is equals to C. ERMS upon BRMS is equals to C. So in this way, and C, what is C? C is nothing but 3 into 10 raised to 8. So in this way, easily you can get BRMS also, and that value will be 9.6. See, BRMS is equals to what? ERMS upon C. Okay, and the value of ERMS that we got here 2.9, right? So if you put the value 2.9 and here you will get 3 into 10 raised to 8, then you will get 9.6 into 10 raised to minus 9 Tesla. So this will be the value of BRMS, students. Okay, so easily you can calculate BRMS also. And once you got ERMS and BRMS, E0 is equals to what? ERMS into root 2. And B0 is equals to what? BRMS into root 2. So that you have to calculate. Okay. Let's see 8.10. A planned electromagnetic wave. The electric field oscillates sinusoidally at a frequency. So this is the frequency given. Amplitude. Okay, amplitude means E0 is given. What is the wavelength of wave? Okay, lambda is equals to C upon F. So C is what? 3 into 10 raised to 8. Here it is given, but if it is not given, then also you should remember that. And this is 2 into 10 raised to 10. So yes, easily you can calculate lambda. Now, what is amplitude of the oscillating magnetic field? Means B0 is asked. So B0 is equals to what? E0 upon C. What is E0? 48. And C 3 into 10 raised to 8. So you can say 16 into 10 raised to minus 8 Tesla. Show that average energy density of electric field equals average energy density of magnetic field. This already we have derived in the previous lecture. Okay. Now these two examples. Suppose the electric field part of the electromagnetic wave in vacuum is this. See, this is a E0. See, I will give you only direction, students. This is a E0 cos this will be the K. Okay, and this 5.4 into 10 raised to 6 will be the omega. What is the direction of propagation? This is positive y, right? Therefore, you can say negative y. What is the wavelength? Lambda is equals to 2 pi by k. See, k is given. So, easily you can calculate. F, frequency. Frequency is equals to omega upon 2 pi. Now, what is omega? Yes, it is given. What is the amplitude of magnetic field part of the wave? So, here E0. So, what is B0? B0 is equals to E0 upon C. E0 you have. So, 3.1 upon 3 into 10 raised to 8. So, you can say that easily you can get and write expression for magnetic field part. See, for magnetic field part, this much remain constant as it is. Only electric field means B equals to B0 like that, and cos and ky plus what you can say ky plus omega t. Now, one thing we have to calculate the direction. First of all, electric field is in the x direction. How I got to know this? This is I cap. So dash cross dash is equals to dash. So electric field first place. So I cap. Magnetic field I don't know. And here it is the minus j cap. So I cap cross k cap, that is minus j cap. That I know. Means what? Magnetic field should be in the z direction. Here it should be k cap. Okay, so easily you can get that also regarding the E. Now, about 5% of power of the light bulb is converted in the visible radiation. So, what is the light energy, real power? Pi into 100 upon 100. So, that is the 5 joule per second as we have calculated in the above example. Okay, what is the average intensity of visible radiation at a distance of 1 meter? Okay, so intensity is equals to power upon area. So 5 upon 4 pi into 1 square means what? 5 upon 4 pi. And at a distance 10 meter, okay, no problem. 5 upon 4 pi into 10 square. So easily you will get that also. Assume that radiation emitted by isotropically and neglect reflection. See, isotropically means what? One is a point and equal radiation is emitted in all direction. Okay, and that's why I am taking here 4 pi r square. Okay, so students, this type of example may be asked in the board examination as well as in the competitive examination. So prepare well for this. Okay, thank you and namaskar.